Let's try to understand multiplication of vectors. We also call it scalar multiplication. In a moment you will understand why. Here is an example. A car is heading due north at 60 kilometers per hour. If v represents the velocity of the car, draw the vector v, 2v, minus v, half v, and give the interpretation for each. Okay, so we know that we are given v is equals to 60 kilometers per hour, right? Now to draw this vector v, let's select a scale. And let's say we have a scale which says 1 centimeter equals to, let us say, 30 kilometers per hour, right? Now we'll use this scale and then draw our vector. So let's first draw vector v. So if 1 centimeter is 30 kilometers an hour, the car is going north, so vector v can be represented by a vertical line heading up, and the length of the line should be 2 centimeters. So let us say this is our line 2 centimeters north. So that becomes a vector, and this vector is v for us, right? And that represents 60 kilometers an hour, right? So this is 60 kilometers an hour for us. So that is v. What is going to be 2v? 2v means it's a vector which has the same direction as v, but the magnitude is twice. That means 2v we can say is equals to 60 times 2, that is 120 kilometers per hour, and the direction will be north, right? Let's say north. So here direction is north. So let's draw this. So 2v is 120 kilometers an hour. So on a scale it should be 4 centimeters. Let's draw a vector which is 4 centimeters. So 4 centimeters will be this much. So this vector for us is 2v, right? So as you can see, when we multiply these vectors by a number, then their magnitude changes. How about minus v? If I do minus v, minus means the direction reverses. So we have a vector now which is 60 kilometers per hour, but it is heading south instead of north, right? So if we have to represent this vector, then on this scale of, that's the scale, 1 centimeter equals to 30 kilometers an hour, this should be 2 centimeters but pointing downwards, correct? So this can be represented as 2 centimeters pointing downwards. So that is like this, correct? So that is 2 centimeters pointing downwards, and that represents minus v. As you can compare, these are opposite vectors, correct? Same magnitude, opposite direction. How about half v? Now if you say half v, that means magnitude is half, right? So half v should be equal to half of 60. That is 30 kilometers an hour, but direction will be same as v, right? Which is pointing north. So on our scale, it will be 1 centimeter. So half v will look something like this. So that becomes half v for us, right? So these are the vectors which we got as a result of multiplying the given vector by a number. So, and what we saw in these cases was that the magnitude changed and the direction also changed. See, when we multiply by a negative number, you can say a real number, then the direction reverses. And if you multiply by a number which is more than 1, magnitude increases. If you multiply by a real number less than 1, then its magnitude decreases. I mean absolute value less than 1. So the effect of multiplying vector by a real number is in change in magnitude as well as in change in direction. Right? That's one thing we learned from here. Second, all these vectors you will note are parallel. Right? And can I say that they are collinear? Collinear means lying on the same line. Are they on the same line? Let's check. If I translate this vector v towards right, it will coincide with this vector. Similarly, if I translate the other two left, then they can also coincide with this vector. So all of them can be lined up into a single line, and so we can call them collinear vectors also. One more thing we learn from here is that if the two vectors are parallel, that means they must be multiples by a real number. We call this real number as scalar now. So what we have done is we have enlarged the definition of scalar. Scalar represents what? Scalar is magnitude, right? We said scalar quantities are those which have just magnitude. How about our real numbers? Do they have direction? No. They have just size, a magnitude. So now onwards, we will consider all these real numbers as scalars for us. So when we say multiply by a real number, we will say some scalar multiplication. So the effect of scalar multiplication is that the magnitude can change, the direction can change, but the vector remains collinear, the vectors are parallel. So that is what we get out of it, right? So that's a very important conclusion. So what all we can conclude is, if two vectors are parallel, then they are scalar multiples, right? Collinear vectors are scalar multiples, right? So that is what we have learned here, and we'll explore and summarize this in the next video. I hope you understand the concept. So what we are trying to say here is that we have a vector, and if we multiply that vector by a real number, then its magnitude and direction can change, but it remains parallel and collinear with the original vector. And this multiplication by a real number is being termed as scalar multiplication. Result of a scalar multiplication of a vector is always a vector, because when we multiply by a real number, the vector does have a direction and magnitude, right? So the result of scalar multiplication is a vector, right? So this is all what we have learned about multiplication of vectors. And we'll apply this knowledge in solving some problems soon. Thanks and all the best.